can go back immediately with the video. So today's lesson is limit of exponential and logarithmic function. And then I also added the second part, which is the indeterminate form. So we are going to start the lesson with the limits of exponential and the logarithmic form. So in solving with the limit of the exponential and the logarithmic forms, there are actually real world situations that can be expressed in terms of functional relationships. So those functions or those relationships are called the mathematical models. So in application of calculus, it's quite important that one can generate these mathematical models because they are sometimes used functions that you encounter in pre-calculus like the exponential and the logarithmic as well as the trigonometric functions. In your general math lesson, you were able to define exponential functions with base b defined as f of x is equal to b raised to the power of x, wherein x there is a set of all real number. And let b greater than 0 such that b not equal to 1. If b raised to the power of y is equal to x, then y is called the logarithm of x to the base of b, denoted by y is equal to log of x base b. So I am not going to tackle about translating from logarithmic to the exponential form because that is beyond the scope of this lesson. You are required to know it because that's part of the general math lesson. Here, we'll be talking about the limit of the exponential, some of the limit of the exponential in the logarithmic form. So first, we consider the natural number. So diba, the f of x is equal to e raised to the power of x. You can guess what is meant this e. Do you have any idea in your general math lesson what is meant by e or why is it that it is e? Can guess? No one from the class is familiar with letter e. Is this the first time that you encounter the symbol e? Oh my god. Yes po. So I was wrong. All of it's the Euler number. That's correct, Pidayo. So I was wrong assuming that you are familiar with exponential function and the logarithmic function. Um, area Ariel was right. It's called Euler number. So when you see Euler number, the value of this, because this is an irrational number, the value of e there is equal to 2718281. I don't do the next because it's repeating in the non-terminating decimal. So the number e, that's one. It's one of the most important numbers in math. Why it's called the most important number? Because it is called, aside from it is called the Euler's number in honor of the discoverer of this number, Leonhard Euler. E is a rational number and it cannot be written as a simple fraction. E is the base of the natural logarithm, which is element. Okay? So, nakalimutan. So I repeat, it's called the Euler number. So we will construct the table of values f of x is equal to e raised to the power of x. Raised to the power of x. We'll start by approaching the number 0 from the left or through the values less than but close to 0. So that's why I ask you to have your calculator kasi bibilisan lang natin to. So first, we have here the limit of e raised to the power of x as x approaches 0 from the left. So what are the numbers from the left of 0? So from the left of 0, we have -1, negative, oh my God, hindi ko siya mabura. Negative 0.5, and then negative 0.1, negative 0.01, negative 0.001. Now, for those students who are not familiar with the Euler number in your calculator, you can have um, this. This one is the Euler number. Can you see it? Okay. So since we are concerned with the Euler number, I mean the limit of the e raised to the power of x approaches to negative, as x approaches to 0. So we'll start here with -1. Where's the negative one? So that will be 3.367. Is it okay if I am not going to show it in my calculator because I'm using, so I can use the the slide? Okay. I hope tama ako na familiar naman pala sa Euler number. So we have there point 367, 0.3678, and then 0.5, negative 0.5, that is equal to 0. What's the answer? 6065. Positive, negative. Oh, it's positive. Positive 0.665. And then raised to the power of negative 0.1, it's 0.9048. And then raised to the power of 0.01, that's 0.9900. Raised to the power of 0.001, it's 0.999. So meaning to say, the limit of e raised to the power of x as x approaches 0 from the left is equal to 1. Okay, now let's take a look with the right hand limit. The limit of e raised to the power of x as x approaches the 0 from the right. So the numbers from the right of 0, we have there 1, 0.5, 0.1, 0.01, 0.001. Can you help me with this? When that's 1, of course, that's Euler number. This is the value, 2.7182. When that is 0.5, 1.6487. When that's 0.1, that's 1.1051. When that's 0.01, that's 1.0100. When that is 0.001, that is 1.001. So meaning to say the limit of e raised to the power of x as x approaches 0 from the right is equal to 1. Then therefore, the limit of e raised to the power of x as x approaches to 0 is equal to positive 1. Am I making myself clear? Excuse me. Okay, no violent reaction. So let us continue. So as an additional to that, when you have the limit of that's a the limit of e raised to the power of x as x approaches to 1, of course that is also equal to 2.718281 because that's the value. And then the limit of e raised to the power of x as x approaches to 2, that is equal to e squared. So that will be 7.389 and so on. Am I correct? E squared. Yeah, e squared is 7.389. Okay, now consider now the natural logarithm of the function ln x. Recall that the natural logarithm of x is equal to log of x base e. So moreover, it is the inverse of the natural exponential y is equal to e raised to the power of x. I hope that you're able to understand this part in your general math lesson, because I don't have the time to recall about converting exponential to logarithm and vice versa, as well as the inverse of their function. So here, let's evaluate the natural logarithm of x as x approaches to uh, 1. So you know the drill. The limit of the natural logarithm of x as x approaches to 1 from the left. So we will construct the table of values. So we have here x and then f of x. We will start with left of negative 1, left of 1 rather is, we will start with 0 0.1, 0 0.9, 0 0.99, 0 0.999. Can you supply the word, the, what I mean is the f of x here? Do I need to show in the calculator what's ln? 0. 0.1, parang mali. Is it negative?
Sir, paano siya isolve sa calcu?
Parang may ln dito. Wala akong ln. Meron ako ln. So we have here the, what's the question nga? Problema. The natural logarithm. This is the ln, oh. Ito. Nakita niyo ln? The natural logarithm. The natural logarithm of, our value is 0 0.1. So it's negative 2.30. Correct? I can use my pen. Yeah. So Ariel was right. Negative 2.30. So let's go back now. Negative 2.30, something like that. And then 0 0.9, that's negative 0. 10, 5, 3, something. 0 0.99, that's negative 0. 0.0100. Negative 0.999, that's negative 0.001. So the limit of the natural logarithm of x as x approaches 1 from the left is equal to 0. It is approaching to 0. You don't need to write negative 0, because there is no negative 0. So here, for the right-hand limit, the limit of the natural logarithm as x approaches 1 from the right. So we have here from the right. So we will start with 1.1, 1.01, 1.001. Isa pa, 1.0001. So the limit of the natural logarithm of x as x approaches 1 from the right, given that x is 1.1, is 0.0953. Double check my answer, ha. 1.01, it's 0.0099. 1.001, that's 0.0009. 1.0000140, so 0. 1, 2, 3, 4 also, and then 9. And therefore, the limit of the natural logarithm as x approaches 1 from the right is equal to 0. Thus, the limit of the natural logarithm of x as x approaches 1 is equal to 0. Yeah, 0.09. So it is approaching to 0. Okay? Let's have the next one. Now we will consider the common logarithmic function. The common logarithmic function such as f of x is equal to log of x base 10. So recall that f of x is equal here to log of x base 10, which is equal to the logarithm of x. We don't need to put 10 as the base because when the logarithm has no base, it is understood that the logarithm is equal to um, the base is 10 rather. Can you give me the limit without solving? Anyone?
Zero, sir.
That's
Zero.
correct. That's correct, 0. Okay, so you know the drill. You'll just get the right hand limit and the left hand limit. When that two right hand and left hand limit are not equal, the limit does not exist. Okay, so we don't need to show the solution. Let's have this one. It's called an Euler number. The limit of what's that? E raised to the power of t minus 1 all over t as t approaches to 0. Give me the limit. You get the limit, the right hand limit, and the left hand limit. Not error. That should not be not error. Ah, sige. May sumagot. Unidentified? No, ano yan? UFO? So let's try to find um, the table of values as the number 0 from the left or through the values less than but close to 0. So our t here, we are computing the limit of e raised to the power of t minus 1 all over t as t approaches to 0 from the left. So say for example, our t is since approaching to um, 0 from the left, we have negative 0.1, negative 0.01, negative 0.01. I think three values will be enough. What's negative 0.1? Isn't it 0.9516? Is the calculator correct? E raised to the power of correct? Oh, mali pala. So negative 0.01, that's 0.999. Negative 0. Should be 0. Negative 0.001 is 0.9995. 5, 0. So meaning to say the limit of e raised to the power of t minus 1 over t as t approaches 0 from the left rather, is equal to 1. Now let's take the right hand limit, e raised to the power of t minus 1 all over t as t approaches 0 from the right. So we have there approaches 0 from the right. We'll be using the same value, the opposite. We use negative zero point 0.1, so we use here positive 0.1, 0.01, 0.001. So when that is 0.1, that's 1.051. When that is 0.01, that's 1.0050. When that's 0.001, that's 1.0005. Thus, the limit of e raised to the power of t minus 1 over t as t approaches to 0 from the right is equal to positive 1. Since the right hand limit there and the left hand limit are equal, then the limit of e raised to the power of t minus 1 all over t as t approaches to 0 is equal to 1. That's correct, Nico and Carl Peter. Question? Okay, let's go now to the indeterminate form. What is meant by indeed? The 0 over 0. Okay, so when you say indeterminate form, there will be, say for example, um, 5 divided by 0. Okay, we always say that it's undefined. Why it's undefined? You could have 1 times, I don't know, 0 divided by 5 pala. Am I correct? Mali. 0 over 0. I'm sorry for that. My example is wrong. 0 divided by 0. I have already the example here. Why it's called indeterminate form? Because you can have an answer which is 1. 1 times 0 is 0. You can have 2. 2 times 0 is 0. You can have 3. 3 times 0 is 0. You can have 4. 4 times 0 is 0. That's called indeterminate form. Okay? So here is the definition of the indeterminate form. Makinig mabuti kasi last year dito, hirap na hirap ang aking mga estudyante sa STEM. If the limit of f of x is equal to 0 as x approaches to c, and the limit of g of x is equal to 0 as x approaches to c, then the limit of f of x over g of x as x approaches to c is called the indeterminate form of type 0 over 0. A limit, you have to keep an ear to this statement. A limit that is indeterminate of type 0 over 0 may exist. To find the actual value, one should find an expression equivalent to the original function. This is commonly done by factoring or by rationalizing. Hopefully, when you are done with factoring or rationalizing, the expression that will emerge after factoring or after rationalizing will have a computable limit, meaning to say the denominator now will not be equal to 0. So we will be needing here the concept of factoring and the rationalizing or the conjugate. Let's take a look with example number 5. The limit of x squared plus 2x plus 1 all over x plus 1 as x approaches to negative 1. The limit of both the numerator and the denominator as x approaches negative 1 is 0. If you are going to substitute negative 1 into the x in the numerator and in the denominator, as x approaches negative 1, that's 0. Thus, this limit is currently written in an indeterminate form of 0 over 0. As mentioned, we have to find an expression equivalent to x squared plus 2x plus 1 all over x plus 1. Okay? So how do we do it? We have here the limit will be, or x squared rather, plus 2x plus 1 all over x plus 1. Remember, the numerator can be factorable as x plus 1, x plus 1. And then we have there the denominator as x plus 1, provided here that x must not be equal to negative 1. So we can now cancel or factor out, thus the limit of x squared plus 2x plus 1 all over x plus 1 as x approaches to negative 1 is equal to the limit of x plus 1 as x approaches to negative 1, which is equal to 0. Clear? I hope so. No violent reaction. So let us continue. I think so. Okay. Now let's evaluate the limit of x squared minus 1 all over the square root of x minus 1 as x approaches to positive 1. Since x squared minus 1 is equal to 0, and the limit of the square root of x minus 1 is also equal to 0, then the limit of x squared minus 1 all over the square root of x minus 1 as x approaches to 1 is an indeterminate form type of 0 over 0. So again, we will find the equivalent limit kasi once we substitute 1 there, it will give us an undefined answer. And how do we do it? How do we do it?
Substitute, sir.
Ano isa-substitute natin?
1 po.
It doesn't make sense when we are going to substitute 1. Kasi when you substitute 1 there, that's 0 over 0. Di ba we have two options? As mentioned, erasing your hand or attention and bond. Factoring or
Try lang, sir.
rationalizing. Bond?
Ma-divide out si, ano, sir, negative 1.
We will divide. I did not get the middle part. We will divide by is factoring applicable in number 6? When we are going to factor x squared minus 1 as x plus 1, x minus 1, may patutunguhan ba yung solution natin? If the answer is yes, sir, walang patutunguhan, then we will do the other way of solving that using rationalizing. Now, normally, when we say rationalizing, we only know rationalizing the denominator. But here, we also have rationalizing the denominator. But it doesn't make sense maglalagay ng radical para mawala ang square. How do we do it? It doesn't make sense if we are going to rationalize the numerator because obviously, there's no radical sign in the numerator. Maglalagay ng radical para mawala ang square. How do we do it? The square root of x squared. So we will do the rationalizing the denominator. It's like multiplying the numerator and the denominator by the conjugate of the denominator. So what is meant by conjugate? Conjugate. Or what's the conjugate of the denominator? Are you not familiar with conjugate? Be honest. It's okay to say, yes, sir, we are not familiar. So, you're honest nga, King. So, we have here A plus BI. The conjugate there will be A minus BI. It's like the opposite conjugate. So, what's the opposite of the denominator? The square root of x minus 1. What's the opposite of the denominator? 1 minus square root of x. Why is it when you say opposite, Hindi siya babaliktarin.
Square
Square
root
root
of
of x.
x
Square root
plus
of x plus 1.
That's correct. So we are going to multiply the numerator and the denominator by the conjugate of the denominator. So we'll have x squared here minus 1 all over the square root of x minus 1. You multiply this by square root of x plus 1 all over the square root of x plus 1. So basically, we did not change the given as x squared minus 1 all over the square root of x minus 1. I just multiplied it by 1. And 1 was represented by the square root of x plus 1 over the square root of x plus 1. Notice that I did not put the limit of the square root of x plus 1 over x plus 1. Okay, so we will have here, let's simplify. Um, you don't need to multiply. You don't need to distribute. You just put the square root of x plus 1 multiplied by x squared minus 1 all over. Here, we have x squared minus 1. It's like a minus b times a plus b. The answer there is a squared minus b squared. That's the concept in the denominator. And then, x squared minus 1 can be factored out as x plus 1, x minus 1. And then, x square root of x plus 1. You can cancel here the index and the exponent, so that will be x minus 1. And basically, the remaining here will be x plus 1, square root of x plus 1. So therefore, the limit of x squared minus 1 over the square root of x minus 1 as x approaches to 1 is equal to the limit of x plus 1, the square root of x plus 1 as x approaches to 1, which is equal to, what is the limit? By 1.
To sir.
Mali. Boy, what happened? Yes. Can we now substitute our C? Our C there is 1. Can we substitute C? Does it make sense if we are going to substitute C? The answer is yes, because that's the reason why we redefine the function. So when you substitute 1, what's the value? The answer is 4. That's correct, 4. Because this is 1. 1 plus 1, 2. This is the square root of 1. The square root of 1 is 1. 1 plus 1 is 2. 2 times 2 now will be equal to 4. Okay? So the limit of x squared minus 1 all over the square root of x minus 1 as x approaches to 1 is equal to 4. Question? Do not forget to write the limit. Why? Usually kasi you are writing this one, it's a false solution. You write the limit of x squared minus 1 all over the square root of x minus 1 as x approaches to 1 is equal to x plus 1. This is the square root of x plus 1, which is equal to 4. This is a wrong solution. Okay? You have to put the limit there because x plus 1 times the square root of x plus 1 is not equal to 4. It's not always equal to 4. So I'd like to stress out the importance of writing the word limit as the operator. Question, violent reaction. Sir, paano po nag-uli ang 4? Ken, palitan mo lang yung x ng 1. Okay, let's have number 7. Can you do it? X squared minus 25. What does f of x appears to be as x approaches positive 5? So you always divide your paper into two. Redefine the function x squared minus 25 all over x minus 5. And then when you redefine it, the answer will be the equivalent function of the given. The answer is 10. Very good. Okay, so let me show you the solution. Or can anyone from the class unmute himself or herself? How did you come up with 10? I want to hear your voice. Sige. Bon, you're raising your hand.
Ano po, sir? Hindi po kasi ako nag-table, sir. Nag-direct lang ako.
That's precisely the reason behind redefining the function. We don't need to use the table because it's laborious task for us. Mahirap.
Okay po, sir. Ano po, sir? Yung si x squared minus 25 po, sir, pinactor out ko po. Naging ano po siya, x minus, quantity of x minus 5 multiplied by quantity of x plus 5
And then?
over x minus 5. Tapos na-cancel out na lang po sa x minus 5. Kaya anong nangyari po, natira sa x plus 5. Tapos substitute po si x or si c. So 5 plus 5, 10 po, sir.
Okay, that's correct.
Kaya,
So let's just make our answer more formal. Although this is correct, so the limit of x squared minus 25 over x minus 5 as x approaches to 5 will be equal to the limit. Do not forget to write the limit of x plus 5 as x approaches to 5. And then by substitution, the answer there is 10. Very good. Here, given that g of x is equal to the square root of x minus 2 over x minus 4, what does f of x appears to be as x approaches to 4? Sige, I'll give you 4 minutes to think how to answer number 8. Ken, do you have the answer? Is it intentional ba when you're raising your head? What's the answer? Wait, bala ko tubig ha. What's difficult with answering number 8? You don't know what to do? Come on. Because here, we are concerned with the limit of the square root of x minus 2 all over x minus 4 as x approaches to 4. Can we do the factoring there? Can we do the rationalizing? Oy, I don't know how to start my solution kasi you're not answering my question. Be honest. What what makes number 8 difficult for you? Hello? Um, undefined? No? Di alam paano umpisahan? It's okay. Mark Lewis, it's not 1. Undefined na utak. 1 over 0. Um, we should avoid 1 over 0. Oh, Gian Anthony de la Cruz got 1/4. Gian, can you unmute yourself? How did you get 1/4? 1/4 is the correct answer. Gian, can you explain to us how did you come up with 1/4? Gian, you. Sige, Ariel, can we hear from Ariel how did she come up with 1/4?
Sir, nag-table po ako.
Ah, okay. Buwis-buhay. um, sino hindi gumamit ng table? Wala. It's okay. So it's okay to use table. The answer is 1/4. That is correct. But here, I'll be solving the square root of x minus 2 over x minus 4 as x approaches to 4 by rationalizing the numerator. So the conjugate of the square root of x minus 2 is square root of x plus 2. So I'll be dividing my solution into two parts. The square root of x minus 2 over this x minus 4. I multiply it by the conjugate of the numerator, which is square root of x plus 2. And then, when I simplify it, that will be, am I correct? Yeah. So we have the square root of x squared minus 4 is like the concept of a minus b, a plus b. So we have there a squared minus b squared. So here we have x minus 4. You don't need to simplify x minus 4 times the square root of x plus 2. And then you can cancel the index and the exponent. You will be left with x minus 4 over x minus 4 and then the square root of x plus 2. And then you would notice that you can divide this as 1. So we have 1 over the square root of x plus 2. So meaning to say, the limit of the square root of x minus 2 over x minus 4 as x approaches to 4 is equal to the limit of 1 over the square root of x plus 2 as x approaches to 4. And when you substitute it, this is 4. The x here is 4. Square root of 4 is 2. 1 over 2 plus 2, that's 1 over 4. I'm not discouraging you to use table. That's the safest way that you can do it. Kaya lang, it's time consuming. And it's nice that you were able to find an alternative solution out of the given function by using the table of values. Because after all, that's the rationale behind why um, we teach the table of values. Kasi yun ang babalikan talaga natin pag nalilito tayo. Let's have number 9. So I'll give you 5 minutes. Question. Sorry. Zero. Is that the answer, Bon, for number 9? O kanina pa to? So, ganun lang. 0 is wrong. Ay, oo nga, no? It should be y. Thank you for that. Y approaches to negative 2. Gian, Anthony got the correct answer. Don't tell me, Gian, it's Chamba. Kasi kanina you got the correct answer eh. How did you get 12, Gian? Galing ng galing po, sir. The answer is 12. Sige, we'll wait for your classmate. Maybe someone can explain why it's 12. Zero din sa akin. No, it's not 0. 12. You're also using table of values, Ariel.
Hindi po.
How did you come up with 12? Sige, let's hear from Ariel.
Sinafter ko po yung y, yung ano po,
Y cubed?
raised to 8 po.
Okay, that's good. How did you factor? What's the factor?
Ano po, y plus 2 times y squared minus 2y plus 4 po.
Very good. Over y
Over
plus.
y plus 2. Tapos makakancel na po yung y plus 2.
That's good.
Then yung y squared minus 2y plus 4 po. Sinubstitute ko po sa y yung negative 2.
That's correct. Very
Then
good.
12 po yung sagot.
Okay? So the limit there is y cubed plus 8 over y plus 2 as y approaches to negative 2 is equal to the limit of y squared minus 2y plus 4 as y approaches to negative 2. When you are going to substitute that, that will be negative 2 squared minus 2 times negative 2 plus 4, which is 4 plus 4, so which is equal to 12. Now, the concept of aerial solution there will be um, cube of a factoring using cube. That's a cube plus b cube. So that's a plus b. And then when you are going to get the second factor, square the first, that's a times a, multiply a times b, but in opposite sign, and then square b, that's b times b. That's the concept here. Very good. Last. This is the last one. My answer is in fraction. So express your answer in fraction. But if your answer is in decimal, it's okay. If you don't know how to start, you have no choice but to rationalize the numerator. So you multiply the numerator and the denominator by the conjugate of the numerator. One half. No, it's not one half. Hula. Give me something. If your answer is one half, George, square root of 2 over 4. That's correct, Aaron. Square root of 2 over 4. Sige, Aaron, can you unmute yourself? How did you come up with square root of 2 over 4?
Yung sa conjugate po, sir. Diba square root of h plus 2 minus square root of 2 over h. Times po sa square root of h plus 2 plus square root of 2.
Okay.
Tapos ganun din po sa baba.
So what's the answer here?
X plus 2 minus 2 po.
That's correct. Over.
over x plus square root of x plus 2 over square root of 2.
Now this one, hindi mo siya sinimplify. Am I correct? So this will be
Square root of h plus 2 plus square root of 2.
no,
Ay,
no. This
1.
part. How to
H po.
simplify this? H, kasi
H
this is 0, over
over
H plus square root of 2. And then, this will cancel out.
opo.
So this is 1. So 1 over the square root of H plus 2. So meaning to say, the limit of the square root of H plus 2 minus the square root of 2 all over H as H approaches to 0 is equal to the limit of 1 over the square root of H plus 2 plus the square root of 2 as H approaches to 0. So you can now substitute. So that will be 1 over 0 plus 2 plus the square root of 2. That is a square root of 2. Square root of 2, 1 over square root of 4. Sorry, 2 square root of 2. And then since that is not yet the final answer, we have to rationalize the denominator, multiplying both sides by square root of 2. So this is a square root of 2 over 4. This is the final answer. Okay, so this will be the assignment. Do not answer. This is activity number 4. Um, answer 31 to 46. Find the limit when appropriate. Do not indicate the limit theorem anymore. Kasi baka isumpa nyo na ako. Do not answer number 31 and number 43 because we're done with number 31 and number 43. Yeah. Any more question? Huwag mo na umalis. I'll be getting the attendance. Okay, if there are no more questions, thank you for joining the class and see you next Monday.